Hello and welcome to this video. So today we're going to be talking about stacks and queues. So this is like the very basic of abstract data types, and I think I did kind of make a video about linked lists, but I think posting that a bit early was a mistake without covering stacks or queues. Now, stacks or queues are much easier than linked lists, and we would like to cover their concepts through this video. All right, and they can be simply achieved by using an array, or you've got built-in functions in Python. Now, obviously, we do not want to go ahead and use built-in functions from Python in order to do this. What we want to do is we want to go ahead and learn the concept so that we can apply it. Although there are built-in functions in Python that you can do it, I'll show it to you at the very end of the video. But for now, we're just going to be going ahead and learning the simple structures of abstract data types. Okay, so first I want to talk about this image right here. So this kind of explains what a stack is in a very basic sense. Well, imagine that this is an array consisting of the letters A, B, and C. All right. So what we consider this to be the top of the array, and what we do is we insert data to a stack from the bottom. So initially, assume that this array is empty. All right. So for example, if I go ahead and do a text, so let's say we've got an array right like that. Okay. So the array is starting from this. Okay. So imagine this is the array. We've got 1, 2, 3, 4 spaces in the array that's empty. Okay. So 1, 2, 3, 4, 4 spaces in the array that's empty. So what we want to do is we want to first take a look at this particular image right here, and we want to take A right here and insert it back to the array. So what we do is we first insert A, okay? So initially this is your top. So this is the top of the stack. Then we want to push in on other data. So the term we want to use is push and pop. So pushing is inserting it to the array. And what we simply mean by that is we are just using this sequence to push stuff into the array. So now our top is changed to this, right? This is our new top. Okay, so the top is going to be pointing to this. Now this variable just indicates the last inserted data. Okay, this is the variable that we would just want to use to monitor what was last inserted to the array. So now, for example, we want to go ahead and insert C to this array. Simply, we just take we just go ahead and put the letter C in, and we just change the pointer to point to the top of the array. Okay, so that's the basic concept of using a stack. So this was a concept of pushing data to a stack. So, and again, until the stack is full, or we could make it dynamic and keep updating on like depending on how much we need to go ahead and do it. Okay. So now what we want is, let's say we have C over here and we want to remove this data, or we want to remove A from the array. So if you're using the concept of stack, we want to go ahead and remove from the top of the array, or this is known as LIFO. The longer form is last in, first out. So the last person inside this array would be the first person that's getting out of the array. So in this case, if I even want to remove A, I need to start off with C. So where do we know what's the position of C? Again, we're going to be using the top pointer right here. So we want to take this top pointer over here and then just go ahead and decrement it by 1. So let's say I'm decrementing it by 1 and just remove C from the array. You can either just decide to keep it inside the array or just remove it so that it's a lot easier when you're working with data. Similarly, once we reach B, we take the top and we increment it once more. I'm sorry, we decrement it once more and we just go ahead and remove B from the array, finally reaching A. And if you want to remove A as well, again, we remove A and we change, let's say, top to a value that's like pointing outside the array. For example, we're changing the value to -1. And when it starts at A, we're going to go at 0. So implementing a stack is pretty much very easy. So for example, if we are talking about an exam people, let's say we're taking a variable named stack, and we're deciding that we want to put 20 of these inside. So for x in range 20. So we want to see that 20 times we're going to be going ahead and multiplying 0. That means we're going to have 20 elements in this stack. All right. Uh, I think we're having an issue with this, so I'm just going to go ahead and put it in a bracket or what? I think stack is a reserved keyword in Python, or is it? Oh, sorry. So for x in range 0, okay. So basically, now if I want to go ahead and let's say print stack, okay, this is going to go ahead and print 20 elements. This is the array. So what we want to do is we want to implement the stack. So we're going to go ahead and click on implementing a stack. So implementing the stack would require us to first initialize the array. So we're going to go ahead and take it to 20, right? So with that being said, let's just remove this. We want to go ahead and put a variable name, let's say top. And initially, top is assigned to -1. The reason being, there's nothing in the stack, anything. So top isn't pointing to anything. This was just literally starting at nothing, right? So what we want to then do is we want to go ahead and push data into the stack. So let's create a function, define push, right? And what we do is we take in an element from the user. Oops, sorry. And this element is going to be going ahead. So we want it, oops, sorry. So for now, let's keep it as pass. So what I'm talking about is this push is going to be taking an element and then putting it into the stack, okay? So what we first want to do is we know that the length of the stack in our case is going to be 20. But again, you can make it dynamic. It's really up to you on how you want to implement your stack. And then we want to go ahead and push it inside the array, right? So what we want to do is we want to put it inside the array in the sequence so that top is also incremented. So you want to first see that if top is less than 20, we want to go ahead and do something. Else, we want to return, let's say, return false. That means the insertion wasn't successful. But if it is less than 20, what we want to do is we want to first go ahead and increment stack. So top plus equals 1. Once we do that, then we want to do is what? Take stack, take the top, and put the element inside. That's it. So we first increment top. So what I want to do is now top is going to be pointing towards, let's say, the first empty space. So top is changing to 0. And then over here, whatever the element is. So let's say it's A. So since it's an integer array, we're taking integer elements, obviously. So what we want to do is if top is 20, and then also we want to return true. Okay, so this is the push function. If you want, obviously, we can do some validation check that if we want to say that if uh, we want to go ahead and check that if it is a number, we would want to go ahead and let's say put it, or we could also do it at this way. So we want to take stack being a global, or what we could also do is we could pass it by variable. So we could just say stack like that and pass it if you want it. So it's really up to you on how you want to do it. We could also uh, do some validation checks. So we could also do that if is digit. So if you want to say that if um, element is digit, or we could also just say if element is not is digit, also we would return false. This would kind of go ahead and give us a small validation check. We would also want to take this as a global. So this would be the validation check. This would be inserting the data to the stack in this case, right? So this is going to be doing it for us. So now what we want to do is we want to also implement a function that kind of does the thing that it says that it would remove it from the stack. So let's say I've inserted another element by calling push. So if I call push and I insert B, then this, um, this right here will change to this index, and we also increment it by 1. So it's changing to the array index right like that, right? So if that's the case, we want to go ahead and do the opposite. If we encounter the element, we go to the top and decrement it by 1, all right? So what we want to do is we want to see def pop. And in this case, we don't want any parameters because pop will literally go through the stack one by one. That's literally the logic of using a stack, by going through it one by one. And we would also know that where stacks are being useful, like for example in reverse Polish notations, where you need to kind of put each digit step by step, step by step, step by step. So what we could do is after doing this, we could also go ahead and create a RPN solver using a stack. That would give us a good knowledge on how stacks work and where to use it practically. But let's go ahead and first implement it. So I'm going to take the global stack over here again. And what I want to see is that if uh, top is less than 0, or we could also say that if top is equal to -1, we would want to return false in this case. That means that it's showing that the stack is already empty. You really don't need to pop anything. Else, that's going to be the case that if top is not equal to -1, what we want to do is we want to do stack, and we want to do top, and we want to assign it to, let's say, 0, and then top is going to be negative equals 1. And then we also go ahead and return true, right? So return true. So return true would automatically go ahead and return that the last element in the stack was popped in this case, right? Okay, so with that being said, let's go ahead and take the stack and push some elements into it and then print it, okay? So let's say I'm calling push uh, once with element 1. Let's say I'm calling push with the element 7, and I'm also calling push with the element, let's say, 10. And then I'm going to go ahead and print. Let's say we want to print the stack and see what's up with it. And then I want to go ahead and pop 2 elements from the stack. So it's going to be logically popping 10 and 7. So let's first try to understand what the program's going to do. Again, the stack is going to be last in, first out principle. It's going to be following that principle. So again, it's going to imagine the array from the bottom. So what's going to happen is it's going to be dumping it into the array one after another. So it's going to first dump in 1. It's then going to be next dumping in 7. And then finally it's going to be dumping in 10 into the array. And top should be logically pointing to 2 in this case. Okay. And we also want to mention that top is also going to be our global variable because we want to change it with each instant. So we want to go ahead and do top in both cases. All right. So with that being said, we also want to go ahead and do this again. What I want to do is print, and then I want to print the stack once again on the terminal to see that if the elements were popped. So it's going to push in 1, 7, and 10. And then I want to pop the last 2 elements. So I'm going to take pop, I'm going to take pop. So it's going to be going and removing this element, and top is going to be decremented back to this, where it is a 0. All right. So let's go and run the code and see what happens. Okay, so I have an issue over here. Let's go ahead and try to see what went wrong. So again, so element, so what's going to happen is element is digit. It actually takes in a string parameter in this instant. So if you're not putting in a string parameter, we're going to be having an exception error in this case. So if I am going ahead and using this method, that's going to be calling it. So what I want to do is we really don't need this validation check at this point, right? So if you want to see that if it is not a integer, then we want to go ahead and do the operation later on. All right, so if you want to do a different validation check on this, let's go ahead and do something else onto it. Or we could just omit the validation check for now because we're just doing an example. So notice that we have 1, 7, 10 in the array, and then we're just having 1 in the array. So the last 2 elements were popped from this array. So what we want to do is we want to go ahead and understand how the push in pop functions in the stack work before we go ahead and work with RPNs. All right. So again, the stack will go ahead and work like this. It pushes from the bottom of the stack and it pops it up from the top of the stack. Okay, that's why we're labeling this variable as top. It's easy to understand. All right. So now let's go ahead and work with something practical. So let's go ahead and create a Python file named RPN. All right. So we want to go ahead and work off with RPN expressions. And before we want to go ahead and we want to say that what is an RPN expression? Where an RPN expression is how a computer would recognize text. I already have a video on RPNs that you can check it out on YouTube. It's already on my channel. So an RPN will help a uh, computer to solve problems by using the uh, order of operations method. All right. So that's how an RPN is going to be helping. Now, again, I already have a video on that, so if you can go ahead and just have a look at that, that would be really helpful. So let's go and take a look at this image just to give you a clear idea. So this is what an RPN expression looks like. So what we want to do, that this expression right here is basically 3 plus 10. But what happens is the computer needs to know the precedence of operation. So this expression right here would be something like 5 times 2 plus 3. But the computer needs to know that which one to do first. So as you can see, that it's going to be coming across elements, and as soon as it detects an operator, it's going to pop the last two elements that the computer stored. It's kind of like recursion a little bit. So it's going to be popping up the last two expressions, and then adding them up or multiplying them or whatever the operator is. So it just needs to focus on an operator. Okay, so that's the important step over here I want to cover using RPNs. Okay, so that's something that you would want to do. So with that being said, let's go ahead and try to code an RPN expression onto the terminal. Oops, just launched the AI thingy. So with that being said, let's go ahead and work on a RPN right over here. Okay. So for example, let's say we have a stack. Okay. So the stack is going to be an array that we're not going to define in this case. The reason being we don't know how long the expression is going to be. Again, in your A-level papers, you might not be required to do something like this, and you will be already given a predefined array. And then we're also going to be having something called a tail that's initially initialized to 1. So the first step is implementing the stack. So implementing the stack. Okay. So this is the stack for the RPN. Okay. So we need a stack for the RPN. So now what I want to do is we want to go ahead and do that for uh let's say I in range. So, okay, so we want to do is we want to go ahead and find the length of the input string, all right? So in this case, that I wanted to go ahead and take an RPN expression as an input. So let's say I'm going to be calling it the RPN token. So we're going to call it the RPN token. That's going to be the expression that we're taking in from the user. So let's say we're taking an input, enter the RPN expression. Again, I would please request you to go and kind of go and watch the video before you kind of watch the video on RPNs before you try to go ahead and watch this one, so you can kind of get a clear picture of what's kind of happening with it. All right. So with that being said, now I want to find the length of the RPN expression. So length can be used from the len function in Python, and then what I want to do is RPN token. All right. So that's going to give me the length of the entire expression. So now I can do for x in range of n. That's going to be going through the RPN expression. So again, what we looked through an RPN expression is, if I kind of go ahead and try to bring this image up once more, is we want to go through each of them until we encounter an element, all right? So what I want to do is we want to see that first, let's try to go ahead and encounter the stuff, okay? So if, let's say, RPN token, so in Python, you have to understand string manipulation. So in this case, I'm going to label it as x. So if it's equal to a plus, or we're going to do the same thing a couple of times, that if it's a minus or if it's a minus, or if it's a multiplication sign, which is going to be this, or this is going to be a division sign, that's an operator. So basically, if it's an operator, then what to do? So if it's an operator, you want to go ahead and take in num1, and from here, what we want to do is we want to take the integer of what's in the stack. So what we want to do is stack dot pop. Now, this pop function is built into Python. You can easily go ahead and implement it. Now, doing this in a queue would be different, which we're going to be covering in a separate video. But for a stack, pop means it's removing the last known element. So let's say this was the last known element 2, and we have a top variable right here, and the last known element being uh, 2 right, last known element being 1 right here. It's going to be removing this element right here. Okay, it's going to be removing that once you're using the pop function. We also want to take out the num2, and we want to put in the integer. So let's say we're going to do stack dot pop. That's going to do the job for us. And then we also want to go ahead and take the tail and decrement it by 2, right? Because we don't want tail over there, right? So if that's the case, then we need to go ahead and make a lot of if statements. So we want to go ahead and do is the if token, and we want to do is x is equivalent to a plus. Again, we're comparing strings over here, so what I want to do is if I want to do is a plus. And I also go ahead and want to just copy this line, so it's making things easier for us. So what I want to do is stack, oops, dot append. So the append function basically pushes to a stack. So it adds an element to the end of the stack. Now in Python, there are 2 of them. Oh, I actually called it token. This is RPN token. So basically, what I'm trying to say is that append will add it to the next plausible element over there. All right, it appends one by one, and it only takes in 1 argument. There's another one in Python that's known as extend, and this takes in multiple arguments. Like it can take different lists. It can take a number of strings like 1, 2, 3, and so on. So it's iterable. As you can see, this is an iterable function. But in this case, we won't only want append. Append only takes 1. So if you actually hover your cursor over append, it already tells it's a def append object any, and it returns none, and appends to the end of the list. So it only adds 1 element to the list. So you want to do num1 plus num2. Okay, so num1 plus num2, and we also go ahead and again want to increment tail because we pushed to the stack. So we push to the stack over here. So push to stack for the RPN expression, and over here we're popping out of the stack. So we're pop out of stack. Okay, so similarly, I'm just going to copy this entire thing, and we have to do it for the minus right here. All right, so we want to do it for the subtraction symbol, we want to do it for the multiplication symbol, and you also want to do it. Now, when you're doing subtraction, it's important to ensure that this is going to be num2 minus num1. Okay, this is important that you kind of take this measure. Similarly, with multiplication, it really doesn't matter, so you're just going to put the star. With division, again, it matters. You want to make sure that this is num1, and this is going to be num2. Okay, and then make sure it pens. This is the calculation, push to stack, and this entire part is going to be the calculation. All right, so with that being said, we're done with this part of the function. Now we need to change something that if this is, we need to change it to elif, because otherwise it's going to be checking all of them. That's going to be decreasing the memory efficiency of our function. So you only do it once, whichever we need it to do it with. So we're just going to change it to elif. Now keeping it to if will also work, so that shouldn't be an issue as well. So again, this if statement should be inside this. I'm just going to go ahead and push everything just to one side. The reason it's inside this if statement because we want to go ahead and put an else statement as well. So why do we need an else statement? Because if it's not an operator, what's going to happen is we need to go ahead and push it to the stack. So if it's not an operator, we're going to go ahead and do that stack.append, and you want to take the string of RPN token, and you want to do I to it. I'm sorry, I'm actually giving an I because I'm used to I more than often. And then we want to also go ahead and take tail and increment it by 1 since we're pushing stuff to the stack. All right. So the final result inside the stack is going to be basically my evaluated expression. So I want to do is return stack, and what I want to do is I. Okay. I'm again giving it as I. That's going to be X. That's going to be the last remaining element of the stack. Not X, actually. We want to go ahead and do the top of the stack. Okay. So that's going to be the top of the stack. And I would want to ensure that, yeah, that's within the so it's within the 4x in range in, and I want to go ahead and do its return. Oh, oh my God, I really didn't make a function. So let's do def calculate RPN. So this function will take in the stack as parameter. It's also going to be taking the tail as parameter, and it's going to also be taking the expression as parameter. Okay, so in this case, the expression is going to be RPN. And then I want to go ahead and I'm just going to put pass over here for now and take this entire chunk of code and paste it here. And I'm just going to go ahead and remove all of this. Okay. We also have top over here. So expression, tail, stack, tail, and expression. Expression is going to be that return stack of top. Okay, so we now have an issue. We just need to push everything to one side, just like that. So this is a function. I was actually using code blocks the other day, and I think that's actually a little bit better in terms of what VS Code is doing than just kind of pushing out the. I need to manually do it, so yeah. All right, so with that being said, that now we have an RPN expression. We have an issue over here. Let's try to solve this. Top is not defined. Oh, why did I write this top? It's gonna be tail. All right. So now our function is done, which is def calc RPN. All right. So what I want to do is I want to sorry, I want to take this entire function, cut it from here, and put it in stack. All right. So append function pushes to the stack. Pop function pops out of the stack. These are built-in functions of Python, and I'm pretty sure you're not allowed to use them in the exam. So make sure you understand how to write your own push and pop functions. Okay. This is really important that you write your own push and pop functions because you cannot go ahead and do that in the exam. Okay. So now with that being said, I'm going to be doing print directly uh, do RPN. So calc RPN. I'm going to put stack tail, and I'm also going to be doing RPN token. Okay. And you also got the length of RPN token. So okay, let's just cut this and put it here. Okay, that's going to make it a lot easier. Print calc RPN. I'll also close this bracket right here, parentheses. All right. So with that being said, I want to go ahead and take an input. So let's go ahead and put in an RPN expression. So let's go ahead and do what it was done here. Okay. So basically, this shows that how this is. So 5 times 2 is 10. Then 10 plus 3 is 13. So this evaluates at 13. So let's put this RPN expression. 3, 5 star plus. So you got 3, 5. We've got 3, 5, 2 star plus. Oops, sorry. 3, 5, 2. We've got star plus. Let's see what happens. The answer it's return. Okay, it's returning 3 for some reason. Let's check what's kind of going wrong with our RPN function. So what we want to do is we want to use int pop, and we've got a tail minus 2. So if RPN expression is a plus, Then we're appending num1 plus num2. If it's a minus, then we're doing num2 minus num1. If it's a star, we're doing num1 times num2, or it's actually the same thing. If it's a division symbol, then you're doing the divide. Do that. I'm actually going to be using the double div so that I'm getting an integer, actually. And then if it's like in the else statement, that else stack that append, we've got RPN token, we've got tail -1, and just return the tail. All right, so I want to see what's kind of wrong with this expression. Let's try to do it again. So we have the expression that's given us 3, 5, 3, 5, 2. We've got star plus. That's giving us a 3. Okay. Uh, cool. So why is it giving us a 3? We want to return stack tail input and expression. So that's going to be the RPN expression. So we've got RPN token. What if we do a separate variable? So we do answer and we do calc RPN and we do stack tail and then we also do RPN token. And then we just go ahead and print ANS. So with that being said, 3, 5, 2 star plus. I think that was the expression. It's still giving us a 3, so I think something is wrong with our logic. That's a little bit embarrassing in the video, but I guess we'll find out together what's wrong. So what we want to do is we have tail that's equal to -1 initially. Or what we could do is instead of taking tail as a global variable, okay, you know what? Let's just cut all these and take them granted for all inside the function. So we don't need these two expressions right here. So what I'm going to do is we want to just remove stack and just take in the RPN expression. Okay, let's see if that kind of works because 3, 5, 2, still getting a 3 no matter what. So it's just popping in the first element and that's it. So it's not working beyond that for some reason. So for x range and length, so we've got RPN notation x plus or double equals, double equals, double equals, double equals. So I think that's still totally fine in my opinion. Uh, I think that's still fine in my opinion. It does look so what we could do division symbol, that's like num1, that's going to be an integer. We want to pop it out. Num2, that's also going to be an integer. We want to pop it out from the stack. So something is it preventing it from appending the results, right, back to the stack for some reason. So what's the catch? What's the catch over here? Stack we want to go ahead and put them. So we want to stack append. Oh, I think I got the issue because this is a string, right? So what we want to do is we want to do the int operator right here. Now let's try it, right? Because we were putting string through the function, right? This was a string. So we need to make it an integer before we can do operations on it. So 3, 2, 5 star plus. Oh, it's still giving me a error with that. Tail, that's also going to be plus equals 1, and you want to return the very last tail that's right there, right? That's also the case. So what's actually wrong with the code? Does it does seem fine to me. Uh, so what I want to do is we have end length. Oh wait, So we're doing RPN token here. What we want to do is we want to do expression. Oh my God. So we want to replace everything. Okay, instead of replacing everything, I just want to replace this with RPN underscore token, right? So I think this should work. So 325 star plus. Okay, that's still giving us a 3. So what's wrong? I'm actually kind of getting a little bit frustrated. Um, so just taking in RPN token as an expression and then using RPN token. Uh, so what we want to do is we've got to do for this. So, right. So, all right. So tail ultimately should give me. Oh, okay. We've got minus 2 over here. Then we also got plus 1. That means we're appending the result to the tail. Right, so oh wait, this is actually inside the for loop. This should actually be outside the for loop because we want to return the final result. I think now this should work. So 325 star plus. There you go. So now we're getting 13 because this was inside the for loop. So every time we were returning stack tail. And the last return element was 3. This is probably outputting 3. All right. So I think that concludes how to go ahead and do or evaluate an RPN expression simply by using Python and simply by using the knowledge of stacks. So hopefully that clears out a lot of confusion. There's a much more simpler and efficient way to write this code since we're writing it in Python. We really don't need tail or anything like that. Because we are using the append and we're using the pop functions. So even if you didn't have like tail function right over here, you could just go ahead and return like stack 0 and it would give the same results. So let's see if I go ahead and do stack. So if I do 3 2 5 star plus, it would still give me 13. So in one instance, to improve the code, what we could do is we could just simply remove tail. We really don't need this if we're using built-in functions. But again, I did this just for the understanding so that you understand the concepts of how a stack works. So basically, if we're removing tail from the entire code, notice that if you do 325 star plus, it still gives us 13. We really don't need to use tail in this instance. Then if you want to improve it, because we're using Python once again, so what we want to do is we don't need n at all. So we don't need to declare additional variables. So what we can do is that for tokens in RPN token, okay, so what we're going to do is if, so we're going to change this expression to tokens. We're going to use in. So this in will determine that if tokens consists of the following values, like a dictionary. So we would see that if token has these following values. So we would do star. We would also do the div operator right over here. Then we could simply do this right here. Okay. So if you want to do that, we've got if not this, tokens. So if tokens is plus, similarly, we could reduce the variable count to if tokens is minus, then we could also reduce this to tokens. Then we could again reduce this to tokens, right, like that. And we could append it to the stack itself, right? So with that being said, then else int RPN expression, you really don't need all this. Just go ahead and do tokens. That's it. Right, so that's going to be kind of giving it and the stack output. So if you want to go ahead and call this again, it's going to be 352 star plus. It's still giving us 13, and the code kind of looks a lot cleaner. Again, we already know what each thing does, so we could just remove push to stack in all cases and make the code look a lot simpler. Just like that, just like that, just like that, and just like that. So this makes the code lot lot more simpler. Okay, so this kind of makes the code look a lot more short. All right. So that's how you're going to go ahead and calculate an RPN expression using stacks. Hope this video helped. I'll be catching up in the next video.